juegues. Nice. But then, you see the speaker, but don't see the presentation.
Yeah.
It's a little dark. It's better from the other side.
How are you?
Sorry, I just some presentation mode.
I get it. So. Oh my gosh, good. How are you? Good. Ready to do this? You're ready. Yeah. Hey, how are you, Brian? I'm so glad you came. We were just trying to figure out. So I have to.
Tan preparado como podría estar, pero
No voy a perder su presentación.
¿en serio? Exacto.
Sí.
Pero estamos tratando de ser apagados.
Porque es
Oh, qué pasa. Okay.
Voy a tratar de instalar como en YouTube. Bueno, se puede ver la luego hasta ahora.
Bueno, lo haré. La muere.
Sí.
Oh, so it all goes on this.
Yeah. Yeah. I mean, it can go
It's hot in here, done anything.
Yeah, it's screen machine.
It's not of course you're gonna sit in there. So it's fun if you're
You're surprised.
surprised. There's nothing here. I couldn't find it. I tried.
That's kind of cool. Picture.
Yeah.
Yeah, turn it on.
Oh, why does Okay, so that's good.
Oh, I'm so sorry. But local technology. No, I'm not.
Okay.
Yeah, okay. I guess they did. I thought that was the text. Oh.
I'm happy to put Okay. Yeah, that sounds good. I do like it if you
I mean, it just, I don't know whether I will see you perfectly. Yeah, we can. How's life?
Life is good. Yeah. I'm really tired from field work, but
It seems like it was really intense.
it
Yeah.
was a good field season. So same old, same old.
Oh, so, so is your plan to apply to any permanent positions, or do you have any in mind? Or
I don't have any in mind yet. I actually was like really enjoying not applying. I applied for a job last year, like crazy end of the like job cycle. To Penn State. I don't know if you saw that one. But it was like a weird position. They didn't even advertise it until like December or January or something. And so I didn't do an interview until really, and then I didn't get like it was like a very weird job. Actually, you know, Laura Acevedo, she was the one who came in.
yeah. She got it?
Yeah.
I mean, but
wasn't compared because he was from there, so they.
Yeah, it was really weird because her advisor, Gary, was
Ahora está por acá. Yeah.
Oh my god, I don't even yeah, I don't know. Kathy and I just got a big grant, so I don't feel like
You need to rush.
I would like to have a job.
No, but I feel like there is a balance because you are doing things that you like, and it's also like a space that allows you to do that. So you can be more picky in terms of where you want to apply. So it's not something similar.
You have
It's,
like the best of
exactly.
not
Yeah,
the project design, but until I get a job.
yeah. You are teaching. You are doing.
Welcome to this dissertation defense seminar that Lauren Snyder is giving. Oh. I have to do it. I don't know. Okay. So, oh, there we go. So, we're all here to listen to Lauren's defense seminar. I just want to remind you of a few things about Lauren. As many of you know, she got her undergraduate degree at Boston University before coming here. While at Boston U, she worked on a project in Texas looking at the ecosystem services of bats in pecan orchards, and so she has this she had this interest in agroecology before she came here. She also spent about 6 months working in Sri Lanka, looking at conflicts, human-elephant conflicts, and specifically interacted a lot with small farmers that were experiencing problems with elephants raiding their crops. And so she came to Cornell to address agroecology in one way or another. And we brought her into our IGRT at the time. We had this IGRT, this NSF training program on food production and poverty alleviation, food systems actually, and poverty alleviation. And so she came in as a student on that grant to start with. And then following that, she got an NSF pre-doc fellowship. So she had a lot of support over her years here, although she also taught and enjoyed teaching a lot, I think. And since she left about a year ago and has been living out in California, where she's been working at the Organic Agriculture Research Foundation, and she's currently the director of research programs there. I probably screwed up the title a little bit, but anyway, that's functionally what she's doing. And it's a real pleasure to have her here today, when she's going to talk to you about the role of crop varietal mixtures in mediating pest control, yield, and economic services in agroecosystems. I do want to track through a little bit of her history, although really, really briefly, here at Cornell. And it's partly because she came in under this IGRT, which was focused on working in East Africa. And indeed, she started out thinking she was going to do her dissertation work in East Africa, in Kenya, in particular on a disease system called maize leaf necrosis. And so she spent her first field season in Kenya working on small farms, surveying the incidence of this disease and getting a general feel for the kinds of cropping systems that people were using. And you're not going to be able to see this well. So I just inserted this one intercrop that she happened to observe in Kenya. And you'll note that it's a maize cabbage. And in fact, cabbage is the instrumental word here because we're going to hear a lot about brassicas today. And so I think this interest in brassicas might have started a little earlier than maybe even she realized. We also did some fun things in Kenya in that first field season. And this is Lauren on a trip to a cave in a very famous cave in Western Kenya with a group of Kenyan students that were her partners, and in particular, Janum, who was a colleague and partner on the project as well. And what you see here is the entrance to the actual cave. It's sort of over here. Most of us sort of stayed out here, including all the Kenyans. But as you might have imagined, someone who's interested in bats, what you see here, it's not really in focus, but is Lauren heading back to the back of the cave. Nobody else would go with her. She was all alone by the time she got to the back of the cave. But bats were a passion. I don't know if you've done anything with bats since then, but not she still loves bats. Coming back to upstate New York, and she ended up coming back and deciding to do her dissertation work here, still interested in food systems, still interested in smallholder agriculture, but in an upstate New York context. And she also did a lot of experimental work, which you're going to hear about today. This is her planting what turned out to be 2 gigantic experiments. Some of you probably helped her on this, is my guess, in the audience. And this is, well, I actually had a video here, but I can see already it's not active. So this is her at the finish line as she dashes through the finish line tape after planting this enormous experiment. And I am happy to be here to introduce her, to talk about her dissertation.
Thank you. Just gonna switch gears really quickly. Thank you so much for the introduction, Sunny, and thank all of you for being here. It's so wonderful to see so many familiar and new faces after being gone for a little while. And I wanted to extend a special welcome to my parents and my brother who are in the audience, and also to Ricardo's family who is joining us remotely. And I want to dedicate the talk to my nephews, Kai and Leo, who have birthdays today and tomorrow, and to their siblings, Jamie and Isa. So I can't imagine a better energy to come here and talk to all of you today. So as Sunny mentioned, I had a very interdisciplinary research path. I'm going to talk to you today about the role of crop varietal mixtures, a form of agrobiodiversity, and their ability to provide pest control, yield, and economic services. So we know that agrobiodiversity can provide many important ecosystem services that ultimately enhance food production. So for example, increased pollination, soil fertility, and even biocontrol pest control services. And in turn, these services provide economic and nutritional benefits that can support farmer livelihoods and food security. So today in my talk, I'm going to break the talk into 3 broad segments. And I'm going to talk about, to begin with, different levels of crop diversity and how these different levels of diversity can influence ecosystem services in different ways. And then I'm going to focus in on crop varietal mixtures and talk about their potential to simultaneously mediate multiple services and interact with larger scales of biodiversity to mediate those services. And then I'll finish by talking about some of the ecological mechanisms that could be underpinning the effect of varietal mixtures on pest control and yield. So to begin, let's look at different crop diversity management strategies. So although we know that agrobiodiversity provides many different benefits, most crop fields, particularly in the United States, look like this one. And so planting fields with one high-yielding crop variety has become the prevailing solution for providing food to a growing human population. And these are very highly managed ecosystems that have been designed to maximize one service, which is food production. And we know that these agricultural systems, regardless of how they're managed, rely on natural areas like this forested wetland pictured here, because it provides food and resources for beneficial organisms like pollinators and natural enemies that can then spill over into agricultural systems and provide beneficial services. So if we come back to this intensified, simplified monoculture here, we would consider it to mostly be a consumer of ecosystem services that are generated from these natural areas. But depending on how we manage these agroecosystems, if we enhance the diversity, we can provide beneficial habitats for organisms like pollinators and natural enemies. And so then these systems become not only consumers, but also provider of beneficial ecosystem services that can enhance food production. And in addition, these diversified systems can support internal processes like soil fertility or pest control that ultimately enhance food production. And so what I'll be talking about today are crop varietal mixtures and their potential for supporting these internal services, but also how they interact with larger scales of agrobiodiversity. And so I've alluded to the fact that there are different scales of agrobiodiversity, which we can see in this illustration here. So at a relatively fine scale, we can think about intra-specific crop diversity or diversity within a single crop species. So perhaps we're growing different varieties of the same crop species together in a mixture. And at a slightly broader scale, we can be thinking about species level diversity. So maybe a polyculture where we have different crop species growing together. And then at the broadest scale, we can think about the landscape that's sitting around us. So we know that these local fields sit within a broader landscape context. And maybe we have natural areas like forests or grasslands, and maybe even other agricultural systems sitting around us. And that can be really important for the dynamics that are happening at these more local scales. So most work looking at how agrobiodiversity affects these ecosystem services is really focused on the species level scale. That's where most attention has been directed. And we know that polycultures are much stronger supporters in most cases of ecosystem services than our monocultures. However, there are a number of logistical challenges that can impede the widespread adoption of polycultures. So as we start growing different crop species, it can be really hard to use mechanized equipment for harvesting or cultivation. And that means that a lot of work now has to be done by hand. And that's an important consequence to consider because labor is one of the most difficult and costly inputs for farmers to procure. And in addition, now that we are having to think about different crop species, we need to know the markets that are associated with those different species and all the growing requirements that each species needs. And so these diversified systems can really be more knowledge intensive and more simplified systems. So over the next few slides, I'm going to use this conceptual diagram to compare and contrast different management practices that manipulate diversity in different ways. And we know that agricultural systems can provide many different ecosystem services. But I'm going to just focus on three up here at the top. So pest control, yield, and human nutrition. And then on the bottom, I have three economic implications that can be very important from a farmer's perspective. So how easy is it to implement that particular management practice? What effects does that practice have on labor and ultimately on profitability? And so in this conceptual diagram, the strength of the service is represented by the length that we achieve on the axis. So as we get farther along with each of these axes, that indicates a stronger service. So let's use this diagram to compare and contrast the two practices we were just talking about, polycultures versus monocultures. And so here in blue, I'm going to show you a hypothetical polyculture, and as I was just explaining, they can be very strong supporters of beneficial ecosystem services. But this can come at the trade-off of being a little bit more difficult to implement because maybe we can't be using the mechanized equipment, which can ultimately affect labor and then downstream also profitability. In contrast, if we consider a monoculture, which I have here in red, due to its more uniform, simplified nature, it can be easier to implement. We can use mechanized equipment, and maybe at least in the short term, it might be more profitable than a polyculture. But this comes at the trade-off for the expense of these beneficial ecosystem services. And so really the takeaway here is that with either management strategy, there are very clear trade-offs, either in terms of ecosystem services or the ability to implement them. So one alternative way that we can enhance agrobiodiversity is to increase intra-specific diversity. And as I mentioned at the beginning, this means increasing diversity within a single crop species. And so I have a couple of iconic examples here. So if you think about going to the Ithaca Farmers Market, you know you can find way more than your average orange carrot. You can find carrots of many different colors. The same is true with tomatoes. Although they're the same species, these varieties differ in very important plant traits like morphology or color. And these traits could be important for mediating pest populations. And there's been relatively little work looking at how intraspecific diversity can affect pest populations in agricultural systems. But research from natural systems tells us that this level of diversity in plant communities can be really important for structuring pest communities, sometimes even more strongly than species-level diversity itself. And so now really the question is to determine how varietal mixtures can enhance pest control and maybe mediate crop damage in agriculture. And so this figure here was adapted from a review by Tucker and Frank, and it shows the predicted pest control services that we could leverage from increasing intra-specific crop diversity in the form of varietal mixtures. And so what we're going to look at here are interactions between the crop, the pests, and the natural enemies. And on the left, I have a monoculture where we have all of the same crop variety being thrown together. And then in contrast, on the right, we have a varietal mixture with varieties that maybe differ in important traits like color or morphology. And so in this monoculture, where we have all of the same crop variety, we probably have very few resources that are going to recruit or attract natural enemies. And so we would expect relatively weak top-down control. And I should mention that the arrows just show the direction of these interactions, and then the width of the arrow is going to tell us the predictive strength of that interaction. And because we have this uniform food base here, we're providing easy access to food for pests, and it can probably be pretty easy for them to locate preferred host plants in this type of situation. So we likely have very weak bottom-up control of pest populations. And because we have this uniformity in these crops here, there's little potential for beneficial synergistic interactions like niche partitioning or facilitation to enhance crop productivity. In contrast, if we consider a varietal mixture where we have varieties that differ in important plant traits, perhaps we're offering more floral or habitat resources for natural enemies, and we might be able to strengthen top-down control of pest populations. And in addition, because these varieties are different from one another, it may be more difficult for pests to locate the preferred host plants. And therefore, we might expect to have higher or stronger bottom-up control of pest populations. And now we also have more opportunity for these beneficial synergistic interactions between plants where maybe we can partition limited resources and enhance productivity, or maybe there's associational resistance in terms of pest control as well. So with this information, I'm going to add varietal mixtures here in green to this conceptual diagram I showed you a few slides ago. And to remind you, blue are polycultures and red are monocultures. And what I suggest is that varietal mixtures in green could serve as an intermediate form of diversification that could enhance ecosystem services relative to monocultures, but reduce some of the logistical challenges associated with polycultures. And so the way that I placed these points on this qualitative diagram was through an interdisciplinary literature review. And I found very strong evidence that varietal mixtures can enhance productivity and yield stability relative to monocultures, particularly under environmentally stressful conditions. And in addition, varieties within the same species can differ in micronutrient content and phytochemical content, which can expand dietary diversity and have beneficial effects on human nutrition. And interestingly, some of these phytochemicals could also be really important in plant defense against insect populations. So we might be able to manipulate this diversity to also achieve pest control benefits. And previous work has suggested as well that varietal mixtures might be a more feasible form of diversification to implement in contrast to something like a polyculture. And that's because farmers can expand varietal diversity in crop species they're already growing. The varieties of the same species maybe have more similar growing requirements and markets, so it wouldn't require extreme changes to existing management practices. But you might notice that I have a question mark next to pest control and profitability because through my review, these are the areas that I found the least research has been done on the role of varietal mixtures in supporting these services. And interestingly, of the studies that have been done looking at how varietal mixtures mediate pest communities, we found very contrasting effects. So in some cases, we've seen effective varietal mixtures, and in other cases, there's just no effect. And in terms of profitability, to my knowledge, there's been no empirical work to examine how varietal mixtures can affect profitability. But we know that if we want growers to adopt diversification strategies, they need to be profitable because these are their livelihoods. So it's a really important point for us to be considering. So in my talk today, I'm going to focus on these two areas, these two knowledge gaps, and show some empirical evidence for whether varietal mixtures can support profitable pest control strategies. Okay, so now that we've oriented ourselves to varietal mixtures, I'm going to dig a little deeper and talk about their ability to support pest control, crop damage, and economic services, and how varietal mixtures at the local scale can interact with broader scale diversity. So as I just mentioned, the work that has been done on how varietal mixtures mediate pest populations has shown these contrasting effects. And one potential explanation for these varying effects could be due to local scale effects. So we know that these fields fit within a broader landscape matrix. And so this variation could be due to spatial variation in the dynamics of insect pests and their natural enemies. So research has shown that the proportion of natural areas of the landscape can affect the abundance of pest communities and natural enemies. And so we might expect that the way that varietal mixtures influence pest populations could vary depending on if we're sitting in a landscape with a large proportion of natural areas versus a landscape where it's dominated more by cropland. And so to account for this variation, I set this first project I'm going to show you within a landscape scale framework. And I wanted to address three main questions. One, do we see any effect of varietal mixtures in the study system on pest populations and crop damage? And if so, is this effect consistent across the landscape, or does it depend on where we're sitting? And then finally, do these mixtures have the potential to serve as a profitable management strategy that farmers might be inclined to adopt? And so, as Sunny alluded to, you will hear a lot about brassicas in this talk. I use Brassica oleracea as my study system because, as you can see here, all of these varieties belong to the same species, which is pretty amazing, but they vary differently in important plant traits like color and also in morphology, which again can be really important for structuring. And I conducted this work in the Finger Lakes region of New York State, so right here where we are. And I focused on two economically important pests, flea beetles and a Lepidopteran Pieris. And in our region, farmers are able to fit in 3 distinct plantings of brassicas throughout the growing season. So they usually can have an early spring season planting, a summer planting, followed by a fall planting. And that's important because the pests have important shift across this growing season. So in the early season, flea beetles tend to be the dominant pest that farmers are particularly concerned about. But in the later season plantings, Pieris and other Lepidopterans become more abundant. And so to account for this temporal variation in pest dynamics, I looked 1 year at a late season planting so that I could capture Pieris dynamics, and then the other year I looked at an early season planting so I could capture flea beetle dynamics. And this slide just shows you that this was a landscape scale study. It was also an observational study, so I used working farms. And you can see that my different study sites are indicated by these yellow markers. And I assessed the composition of the landscape by looking at the percent of cropland surrounding each of my field sites. And so to determine if pests could be responding to varietal richness, I selected farms that were already growing just one variety of Brassica oleracea in a plot, so that would represent low varietal richness. And then I found plots that had up to 6 different varieties being grown together to represent high varietal richness. And then I found plots that spanned a gradient of landscape complexity. So in our region, landscapes that have a low proportion of cropland tend to be dominated by grassland, pastures, forests, And so these would represent more complex landscapes. And then moving into more simplified landscapes that have a higher proportion of cropland in them. And I had both low and high richness sites across this gradient of landscape composition. So in each field, I measured varietal richness by counting the number of varieties that were present in each field. And I also looked at an associated plant trait color to see the number of colors that were present as well. And multiple times throughout the year, I visually counted pests and assessed crop damage. And as I was working with zero inflated count data, I used manual fertile models to analyze the data. In my second year of the study, I was able to convince a subset of farmers to give me access to their farm records. So I was able to incorporate the economic component of my study. And by having access to these records, I could create crop budgets that just allow me to track inputs and outputs to each field so that I could get some measure of profitability and sites that had low varietal richness versus sites that had higher varietal richness. And because I had a lower sample size, I just want to note that the data that I'll be showing for this is just at the local scale. I wasn't able to capture landscape scale dynamics. So over the next few slides, I'm going to show you a few figures that look like this one. So I just want to take a moment to orient you to what we're looking at. So in general, this figure is going to tell us if the effect of varietal richness on pest abundance, or pest incidence, on the y-axis, is consistent across the landscape. So on the x-axis, we just have the number of varieties in each field, and then we're going to be moving from complex landscapes with a low proportion of cropland over to the left to more simplified landscapes that have a higher proportion of cropland. So let's look and see what flea beetles are early season pests, how they responded to varietal richness across the landscape. So here we see a very interesting interaction between varietal richness at the local scale and landscape composition. And here we see that as we increase the number of varieties in a field in complex landscapes, we increase the probability that we're going to find a flea beetle in that field. So in these landscapes, it might not be the best idea to be implementing a varietal mixture. But as we shift into more simplified landscapes that are dominated by cropland, we see a significant reversal in this trend. And now it's actually beneficial to increase your varieties because there's significantly lower incidence of flea beetles in these landscapes. And so what this tells us is that we really want to be thinking about landscape context when we're making recommendations to growers because the effectiveness of this local scale practice is not consistent across the landscape. Now if we look at Pieris, which to remind you was the lepidopteran pest that's more abundant later in these late season plantings, we see the opposite trend. So now in complex landscapes, it is beneficial in terms of reducing Pieris abundance to increase the number of varieties. But as we move into simplified landscapes, we lose any effect of varietal richness. And so here we would probably expect to see only an effectiveness of this management strategy in these more complex landscapes. One reason we may not have seen an effect in simplified landscapes is because Pieris happen to be significantly less abundant in those landscapes compared to complex landscapes in our study, which might seem counterintuitive at first because we would expect there would be more food resources for Pieris in landscapes dominated by cropland. But also these landscapes tend to have higher background levels of pesticides compared to more landscapes dominated by natural areas. So it could be that these pesticides were just effectively controlling Pieris and limited our ability to detect an effect here. So having seen this effect of varietal mixtures on both pest species, I wanted to dig a little deeper and see if a particular crop trait color could be partially responsible for the effects that we observed. And so I took advantage of the color variation in the species, and I looked at the number of colors planted in each field. And I chose color because previous work has shown that lepidopterans and Pieris in particular use color as a landing and over-positioning cue. And they tend to be more attractive to green varieties of Brassica oleracea as opposed to other colors such as red varieties. So I'm going to show you a figure that's very similar to the first one. And the only thing that's going to change is now on the x-axis, we'll be looking at the number of colors rather than the number of varieties. And what we see here is with Pieris, the same pattern with color richness as we saw with varietal richness. As we increase the number of colors, we see a significant reduction in the abundance of purus. But again, this effect is only significant in complex landscapes. And we lose this effect as we move into more simplified landscapes. And this is interesting because in our data set, varietal richness and color richness were independent of one another. They were not collinear. So this tells us that purus really is responding to color as an important crop trait in addition to overall varietal richness. We did not see an effect of color richness on flea beetles, which suggests that they are responding to interspecific variation in a different crop trait, perhaps something like morphology or chemical use. And despite seeing this effect of varietal mixtures on pest populations, neither varietal richness nor color richness explained crop damage in our study. Rather, the most significant predictor of crop damage was just the percent of cropland in the landscape. And we saw a negative correlation between cropland and damage. So why might this be? Well, remember that I mentioned that in these more simplified landscapes, purus in particular was less abundant. And we also know that these pests are significantly associated with crop damage. So higher abundance of purus is associated with higher crop damage. So it could just be that purus is less abundant in these simplified landscapes and is contributing less to overall crop damage. So now that we've looked at how mixtures and landscape can interact to affect pest control, let's move on to the second part and see what the impact is on profitability, which is a really important metric from a farmer's perspective. And interestingly, what we found with this data set is that, again, varietal richness was not important in predicting profitability. Rather, a functional trait, the number of colors, was the best predictor. And what we see is that in plots with 2 colors, we have significantly higher profit per plant than in plots with 1 color. And even here, this is a really bad scenario to be in because looks like you're losing money from these plots. And what we also found was a marginally significant reduction in labor costs in plots with 2 colors. And that's really encouraging because remember I mentioned at the beginning that labor is one of the most difficult inputs for farmers to procure, particularly in the United States. And so if we can find diversification strategies that can affect pest populations and not come as a trade-off of labor, that could be a really valuable tool for farmers to consider implementing. So to summarize this portion of the talk, we do see a significant interaction between this local scale level of diversity, varietal mixtures, and rural landscape. And in addition, the effect of varietal mixtures varies across not only the landscape, but also depending on the pest species that we're looking at. And so this is interesting for a number of reasons. So this variation across landscape context could be one of the reasons why previous studies have found mixed effects of varietal mixtures on pest populations, because no previous studies have taken landscape into account. And in addition, if we're thinking about how to provide recommendations to farmers, we need to be thinking about landscape context, but also the pest species that we're trying to target. So something that might be effective for targeting Lepidopteran might actually exacerbate a problem with flea beetles. And so it's really important that we're considering these multi-species systems and also where we're sitting in the broader landscape as well. So to come back to these original questions, we did see that varietal mixtures can affect pest abundance. We didn't see an effect on crop damage that was more strongly correlated with the percent of landscape surrounding the field. And if we can manipulate or design varietal mixtures to have variation in the right plant traits, in this case color, they can be a profitable management strategy. And we do see that this effect varies across the landscape, so it depends on where we are sitting, what type of effect we're going to see. And so now I'll move on to the last portion of the talk where we can look at some ecological mechanisms that could be explaining or underlying these patterns that we saw in this landscape scale study. And in particular, I wanted to know what mechanisms could be driving the effect of mixtures on pest abundance and crop production. And by crop production, I'm going to be looking at not just yield or quantity, but also crop quality by assessing crop damage. So if you recall at the very beginning of the talk, I mentioned that most research looking at this relationship between biodiversity and ecosystem processes has really focused on the species level. And we often see trends like this, where as we increase the number of species in a plot, we see some benefit in terms of an enhanced ecosystem service, whether it's productivity or pest control. And the literature from this research has put forth two broad hypotheses that might explain this trend here. One is that it could be diversity per se that's driving this effect. So by including more species together in these polycultures, we get these emergent effects like facilitation or complementarity that can enhance productivity, or something like associational resistance, where we see a benefit in terms of pest control. The alternative is that identity effects are driving these trends, and it's really the presence of one particularly influential species that is driving these plot level dynamics. And so while these hypotheses have been developed from species level research, they could be a really useful framework for us to implement and look at varietal mixtures. So that's what I did in this study, was I wanted to understand whether varietal richness or diversity per se was driving this effect of mixtures on pest populations and crop production, or if it's really the presence of a particular variety that's driving these plot level dynamics. And again, enter brassicas. I used this study system and took advantage of the broad trait variation present here to test these hypotheses across two plant traits. Again, color, but also interspecific variation and crop morphology. And in this study, I focused on Lepidopteran pests. So again, we'll be looking at the abundance of Pieris, but also of Frutella xylostella, which is another economically important pest in our region. And so as I mentioned, I tested these hypotheses across two crop traits, and I did that by conducting two separate common garden experiments. And in the first experiment, I manipulated morphological variation by selecting 3 varieties of brassicas that vary in plant structure, so cabbage, broccoli, and kale, and I grew those in monoculture, all possible 2-way combinations, and then finally in a triculture. And I replicated these 7 treatments 6 times in the field. And then I had an identical experiment or a parallel experiment where I manipulated color diversity. And here I kept plant structure constant, so I had 3 different varieties of cauliflower that just varied in color. So I had a white, a green, and a purple variety that I grew in monoculture. Again, in all 2-way combinations, and then in triculture. And again, these were replicated 6 times in this common garden experiment. And this picture just shows you what the setup looked like in the field. This is part of the morphology experiment where we were growing different combinations of cabbage, broccoli, and kale together. So if we return to our hypotheses and think about what mechanisms might be driving these effects, I'm going to use pest abundance as an example. So if varietal richness or diversity is really driving the effect of mixtures, what we'd expect to see are significant differences in pest abundance across plots depending on the number of varieties that are being grown there, regardless of composition. So averaging together the monocultures, the biculture, and then the triculture. But if varietal richness is not the mechanism at play, we would expect to not see any difference across these different treatments. The alternative is that the composition of these mixtures really is important. And here we would expect to see significant differences across our 7 treatments, as denoted by the different letters here. And so in yellow, I have all the monocultures, in pink are the bicultures, and then blue is the triculture treatment. And so then to look for identity effects, it's going to be a 2-step process. First, we're going to see whether or not any varieties behave the same in monoculture as they do in mixtures. And so in this hypothetical example, we would see this with variety 2. So monocultures of variety 2 behave the same as mixtures that contain that variety. So that's the first piece of evidence that this is a particularly important variety in terms of mediating pest abundance. And the second thing we'll do is a set of pre-planned contrasts. And all that means is that we're going to look at, for each of the 3 varieties, look at plots where that variety is present, which will always be represented by blue, versus where that variety is absent, which will always be represented in orange. And if we see significant differences in pest abundance or damage or yield across plots plots with and without a particular variety that would confirm that that variety is contributing to an identity effect. If there are no differences, then we would assume that that variety is not particularly influential for that particular service or process. Okay, so let's start by looking at the results from the morphology experiment, and to remind you, that's where we're growing different combinations of cabbage, kale, and broccoli together. So we see no effect of varietal richness on any of our variables, on any of our response variables. So across pest abundance, damage, or yield, the level of varietal richness in our plots does not predict any of these services. However, varietal composition, varietal composition is important. And so again, we look across our 7 treatments. Yellow is monocultures, pink are bicultures, and blue is a triculture. If we look at the abundance of Pierre's egg, we do see significant differences across our 7 treatments. So that means that the composition of these mixtures really is important to this test. And you might notice that there's a subset of treatments that have particularly high pest abundance. And if you look a little bit more closely, you'll notice that they all have broccoli in common. So this is our first piece of evidence that broccoli is a particularly important variety in these mixtures. And amazingly, we see the same trend if we look at Pierre's larvae. We see again the subset of treatments that have higher pest abundance. And again, they all have broccoli in common. And finally, if we look at Frutella, the abundance of Frutella larvae, we see a similar trend where broccoli seems to be a particularly influential variety that is in mixtures with higher pest abundance. And so now we'll look at these pre-planned contrasts, and we'll look at broccoli first. So what I'm showing you here are plots in blue where broccoli is present versus where it's absent in orange across our pest species. And we see that consistently across these pests, plots with broccoli have significantly higher pest pressure. And so this suggests that broccoli is exacerbating the pest problem in these mixtures. And if we do the same analysis for kale, it also looks like kale is important because we see significant differences between plots where it's present versus where it's absent. But it behaves in the opposite direction of broccoli. So actually, kale seems to provide a pest control service by reducing pest pressure when it's present in a mixture. So now let's see if these effects on pests translate into any effect on crop damage. And what we see here, again, are differences across our treatments. But interestingly, we see this benefit of certain varietal combinations. So if we look at monocultures of broccoli versus mixtures where broccoli is planted with kale, or it's both kale and cabbage, we see a significant reduction in crop damage when we include these other varieties of broccoli. So there's this benefit in terms of reducing crop damage relative to just having a monoculture of broccoli. But we do see evidence that kale could be contributing to an identity effect, again, because monocultures of kale behave the same as mixtures where kale is present in that mixture. And this result with kale is confirmed when we look at crop damage across our 3 varieties when either that variety is absent or present. And when we are looking at kale in particular, we see that plots where kale is present have reduced crop damage relative to when it's not there. And that makes sense because, remember, we also saw significantly reduced pest abundance in plots where kale was present. So this seems to be translating into an effect on crop damage as well. Okay, so now we'll move to the results from the color experiment. And to remind you, this is where we're holding plant structure constant. We're looking at 3 different colored varieties of cauliflower, white, green, and purple. And we see the same non-effect with the color experiment as we did with the morphology experiment. So varietal richness does not explain pest abundance, crop damage, or yield. So again, varietal richness doesn't seem to be the primary mechanism that's driving the effects of mixtures. And I'm going to focus just on showing you data from Frutella in the color experiment because we saw no effect of the color experiment on Pierre. So again, here we see that across our 7 color treatments, there are differences in terms of our Frutella abundance. And here it looks like this green variety of cauliflower is particularly important because when that variety is planted in monoculture, it behaves the same as mixtures that also contain that variety. And we look at plots with and without each variety. That effect is confirmed. So for when the green is present and denoted by blue, if there's higher pest abundance than when it's absent in orange. But it doesn't look like the white or purple varieties are particularly important in terms of mediating abundance. And now if we think about crop damage, it seems that actually the composition of these mixtures is more important. So we see a similar effect with this green variety as we did with broccoli, and that if we can grow this green variety with a purple variety, we see a significant reduction in crop damage compared to just monocultures of that green variety. However, we lose this effect if we plant the green variety with the white variety or both the white and purple. So if I'm a farmer, I really need to think carefully about how I'm combining these different varieties because I could either exacerbate a crop damage problem or I could ameliorate it. So if we look at across again the three varieties when they're present versus absent, despite seeing that beneficial effect of growing the green variety with the purple, the green variety still seems to be particularly influential, and when it's present, there's higher damage than when it's absent. So this variety seems to behave similarly to broccoli in the morphology experiment. And we're also picking up an effect of this white variety. And that's kind of interesting because we didn't see the white variety being very important in terms of mediating pest population. However, there was a non-significant reduction in pest populations when the white variety was present, which could have translated into this significant effect on crop damage. So to summarize, across two crop traits, both morphology and color, we see that identity effects seem to be the important mechanism driving the effect of mixtures on pests and crop damage. And so certain varieties can exacerbate a pest problem, whereas other varieties have the potential to reduce a pest problem. And despite seeing effects on pests and damage, we saw no effect either of varietal richness or identity effect on crop yield. And despite that, I think it's important to think about as we consider the implications of this result, that marketable yield is a really important metric for farmers. And marketable yield is determined not just by quantity, but also quality or damage. And we did see an effect of some mixtures in terms of reducing damage. So that suggests that different mixture combinations or certain mixture combinations could have an effect on overall marketable yield. And in addition, the fact that we saw a reduction in pest population is important, even though it didn't cascade into a yield effect. And that's because farmers are making decisions about when they're going to apply inputs like insecticides way before they've harvested the plant and they know their yield. They're making these decisions based on pest pressure. So if we can find management practices that reduce pest pressure, we have a potential to reduce insecticide usage, which not only has economic but also obviously environmental benefits as well. So to return to the primary research question, we see that varietal mixtures can be important for mediating pest populations, but this effect really is dependent upon the landscape in which we sit. And if we really are thoughtful about the functional traits that we're manipulating in these mixtures, these have potential to be a profitable management strategy. And we should look further into how identity effects might be driving the role of mixtures in terms of pest and crop damage. And so if we return to this conceptual diagram that I showed you at the beginning of the talk, I want to note briefly that I've changed this blue line that represents a hypothetical polyculture into a dashed line. And that's because I didn't empirically test the relative importance of polycultures and varietal mixtures. I really mostly focused on how varietal mixtures relate to monocultures. But we'll just keep this here as kind of a hypothetical scenario. And what we can do is change these question marks into actual points based on the data that I've shown you today. And so if we are in an idealized scenario where we're sitting in the right landscape and we really thoughtfully design these mixtures, we can enhance pest control relative to monocultures. And they also appear to have the ability to support higher profits relative to monocultures, again, if we're thinking about what crop traits we're really enhancing in these mixtures. And so there are a few key key takeaways I want to leave you with. Given the identity effects that we saw in both common garden experiments, it's clear that we really need to thoughtfully design mixtures, because if we choose a particularly influential variety, that variation alone might make it appealing to plant a monoculture of the most superior variety. However, I would say that the rest of my research shows that there are a few potential drawbacks to that strategy. One, if we choose the wrong variety to plant in monoculture, we're kind of screwed. Because think about how planting just a monoculture of broccoli or the green variety significantly exacerbated a pest problem. And in addition, my landscape scale research shows that mixtures have the potential to provide other services outside of pest control, primarily economic services. But we can only achieve that if we enhance something like color richness. And so if we plant a monoculture, we automatically forego any possibility of these other services. And in addition, we did see instances where planting certain compositions of multiple varieties was beneficial. So think about the reduction we saw in crop damage from broccoli monocultures compared to if we grew broccoli with cabbage or with kale and cabbage. So we should really be thinking about how can we design these win-win situations that help farmers maximize multiple services. And so based on my research, I think there are a number of areas of future research that are very exciting. We know that landscape context is extremely important. And so I think it would be really neat to kind of combine the landscape scale study with this common garden experiment to see whether or not the same mechanisms, varietal richness or diversity versus identity, are at play depending on where we sit in the broader landscape. And really, how much diversity do we need in these mixtures? So in the landscape study, I had up to 6 varieties growing together, but in the common garden experiment, I only had 3 for logistical reasons. So might we have seen different mechanisms driving the effective mixtures if we had enhanced varietal richness more, or maybe we would have seen an effect in the field if we had higher varietal diversity in these plots? And what other functional traits might be important in mixtures? So my research suggests that color is an important trait and perhaps morphology as well, but we know that other functional traits are also important, such as the chemical profile differences in these different varieties. And we also know that traits like color can correlate with plant chemistry. So teasing apart whether it's actually visual cues of color versus chemical cues of color would be really interesting. And I would encourage us to consider multiple services simultaneously, because if we're thinking from a farmer's perspective, they don't have a myopic focus on just pest control or just yield. They're simultaneously trying to manage systems to achieve multiple services. And so understanding how we can create these systems to really maximize multiple services is important from a food systems perspective. And so with that, I'm going to save my acknowledgments after questions, because I know myself and it might get a little emotional. So with that, I'm happy to take a few questions, and then I want to have a moment to acknowledge the very important people that have been pivotal in this process. So.
Very nice presentation, very beautiful data. I'm particularly interested in your opposite patterns along the landscape level for your butterflies.
Okay.
So you kind of gave an explanation for your butterflies, but you didn't give one for the
I'm so glad that you asked, because I wanted to talk about it, but I didn't want to spend too much time on that slide. So let me just go back. So it's a bit of a complicated explanation, but what we're thinking is that we know that other beetles can induce these detoxification enzymes in response to increased diversity in phytochemicals, which is an enzymatically costly process for them to go through. And in simplified landscapes where we have usually higher background levels of pesticides, we know that insects can induce a similar detoxification process. And so it could be in these simplified landscapes where we're sitting in fields with a lot of phytochemical diversity, we might assume, pests are having to deal with detoxifying not only a suite of phytochemicals, but also pesticides. And so that could be a deterrent for having them move into fields where there's a lot of this phytochemical diversity. Whereas if we're in a more complex landscape where pests don't have to deal with background levels of pesticides, we know that this can also, these different nutrients in the plants can also benefit pests sometimes in terms of enhancing their dietary diversity. So perhaps in these more complex systems, there's some benefit of them feeding on different crop varieties and having access to these different plant nutrients. But would love to hear maybe what your thoughts might be on that.
It's an interesting thought. It's a very interesting thought, but you're kind of explaining the same thing for one species oppositely for the other species can do that. Right? And what I was kind of trying to get at, do you think, especially because it is kind of the earlier season, do you think that simply the presence of one excludes the other? Could that theoretically be?
It could be. They do overlap at some point in the season. But also, flea beetles tend to be more of a problem at different plant stages too. So when the brassicas are young, that's when they're more abundant. And as the plant matures, you see fewer flea beetles and more lepidopterans. So there could also be these interactions with the metro too that might actually. Yeah.
I would say also just the natural history that's lived there, like the butterflies that they nectar or something, because the beetles just live in their roots and the plants. Butterflies get the plants.
Yeah, the adult butterflies need floral resources, whereas with flea beetles, that's not necessarily the case. And in addition, that's a good point, Anji, is that in our system, there are natural enemies that provide effective control of pests, which may be more abundant in these complex landscapes. But we don't really have natural enemies that provide top-down control of flea beetles. So it could also be having another trophic level interacting in addition to like history traits as well. Yeah.
I think it's
all over both the past plots and maybe
Oh yeah, that could be. But then I guess I would also not necessarily expect to see so much of an effect of the varietal composition because we did see higher pest abundance in certain mixture combinations than in others. One thought I had about that is that actually this landscape slide is good to have up because the experimental station that I used to do the common garden experiments, I tried to control for landscape variables that was just done in one place. And it was surrounded by a relatively high proportion of cropland. So it sat in a landscape that was about 55% cropland. As you see here, lepidopterans didn't respond to varietal richness in these landscapes. So it could actually be a landscape effect that made it more difficult to see an effect of varietal richness here.
With the cabbage, kale, and broccoli experiment, do you feel like to make recommendations for individual growers that they might have to do their own tiny experiments on their own land because of the landscape context? And you won't really know exactly like in the landscape context you won't broccoli that's so terrible this time or something like that.
Yeah, absolutely. And they might be growing other crop varieties that are not those three that we looked at. So definitely, I would feel very uncomfortable making any strong recommendation, but would recommend that a farmer try it on a small scale, maybe next to a plot of some like existing management practice to see how it might affect pest populations and acreage.
So before you dug into the composition, I think when you're just looking at richness overall, you said color richness increased profitability, right? But you said kind of, I think you said varietal richness has no effect on profitability. So if they mix varieties, they weren't losing out in this, right?
So, true, yes. So there was no negative consequence of mixing varieties. kind of similar profits. So maybe and that's really a great point because this is kind of the benefit about thinking about multiple services. Maybe we get some pest control benefits and we can reduce our input and it doesn't come at the cost of farmer profits.
Yeah, so we share rich rate.
Yes, yeah. I think I saw another hand up here.
Very interesting presentation. Thank you. And my question is that you give a map of different planting scale. One is monoculture, another is different variety, and another is multi-planting, right?
Yes.
And in your experiment, you made the monoculture and the different variety culture, and you do not do the experiment about the multi-culture. How can you tell the effect of multi-planting and different varieties?
In the second part of the study, or the talk, so I had monocultures of just broccoli, just kale, and just cabbage. But then I also had mixtures where I was growing broccoli and cabbage together, and cabbage and kale together. So those were the treatments where I had multiple varieties planted in the same field. So I did have multi-variety mixtures as well in the common garden experiment. Okay. Does that answer your question? Maybe I can go back to this. So in the setup, so I had monocultures of just the white variety, monocultures of just the green, and monocultures of just the purple, and then I would grow green and white together and white and purple.
But they just belong to the different varieties. They are all the same species, is that right?
Yeah, throughout the whole experiment, they're all the same species. So I'm just looking at how varietal variation within the same species can mediate these different surfaces.
I want to see a slide.
Which one?
The dashed line.
Oh, I see. Oh, okay. This one?
Yeah.
Oh, okay.
My question is that, for example, you have a question mark here.
Yeah.
And in your experiment, you compare the red line and the green line.
Yeah.
But you did not do the experiment about the green line and the blue line. How can you tell their
Yeah, so that's a great question. So that's just a hypothetical scenario, and here this would be actually a conservative relationship. So I'm suggesting that in green, varietal mixtures would have weaker pest control than polycultures, so I took a conservative stance. But actually, research from natural systems has shown that that green line could go beyond the blue line if we're increasing interspecific diversity in a dominant plant within a community. So you're right, I did not specifically test the relative effect of polycultures and varietal mixtures, but I placed the lines such a really conservative relationship between the two. Does that address your question?
Yeah. Okay. And another question.
Okay.
Different variety cabbage. Yeah, no experiment you have done that. And maybe their order can affect the pest population. Did you consider this?
Odor?
Order. You have the 6 variety of cabbage, is that right?
No, just one variety of cabbage in the common garden.
Different color.
Oh, the cauliflowers?
Yeah.
In the color experiment here?
Yeah, I consider whether the different order you plant them in the field.
Oh, the different orders.
Different order maybe affect the pest population.
I had the same within plot design, but I used fully factorial random block design so it was very mixed where the plots sat next to one another to try to account for any effects like that. Yes.
So you might not know the answer to this, but do you think that these results could be applied to a situation where your interest in varietal and you have two different crops? So like different varieties of green kale that are less obviously diverse but have different levels of pest resistance to things and back to the varietal.
Yeah, that's a great question. And so I chose this system because closest I got to it was with this cauliflower experiment, and we did see effects. And actually, most work on mixtures, there's been so much research on how mixtures can affect disease, so for disease control programs, and those have really been done in cereal and grain crops, which if you think about like structurally are pretty similar to one another, and it can be very impactful for reducing disease pressure. And there's been research too, especially in terms of yield. Most of the research looking at the effect of varietal mixtures on yield have been done in these cereal crops that are more similar, and we do see significant effects. But if we wanted to think about something like just different varieties of kale, you would really need to think about what functional trait you're manipulating. So is there like a certain gene that's changing that would confer some type of resistance or maybe draw on a natural enemy or something like that? So you really have to think more and think about the traits that you are incorporating in your plots. Okay, so then I'll go to my acknowledgements. Sorry, you're not all yet. So first I want to thank my committee, Sunny, Katya, Jennifer, and Miguel, and I have them all up here together. I'm going to talk about each of them individually for a little bit, but they just were such a great, wonderful combination of people. Every time I had a committee meeting, I just knew that it was going to be a very welcoming environment and atmosphere, and they just complemented one another so well and really supported my interdisciplinary research inquiries. And being in Sunny's lab, I feel very appreciative and grateful for all that she's provided me over the past 7 years. And one of the biggest things is that Sunny really just cultivates a very kind atmosphere in her lab and brings in people who are not only brilliant scientists, but just wonderful human beings. And I like this photo of her and Alex because I think it shows her natural curiosity. And so she would get very excited about many different questions, just like myself. So I think we have this shared passion for looking at really complex, diverse food systems where there's so many different factors changing at the same time. And she gave me a lot of freedom to address the questions that I was most interested in. So I thought when I first started that this was going to be my title slide for my dissertation. And so instead of working on elephants, I moved down to flea beetles, which seems like a pretty logical transition to me. But Sunny was just really supportive of me figuring out what system made the most sense for me to address the questions I wanted and made the most sense for the lifestyle I wanted to have while I was here in Ithaca. And she was supportive of me taking this non-academic job and moving out to the West Coast and getting this experience with a nonprofit, which I don't think is everybody's experience, and I'm very grateful that she just wanted me to use my skill set in the way that felt right to me. Katya, I love these photos because you just see her very calm concentration and just her compassion, and she's such a remarkable scientist. I admire very much the way that she asks these scientific questions and is so good at distilling messy data into a clear story. But she was always just so compassionate and thoughtful with the way that she communicated her critiques and helped me to improve my work, has been there for me during very stressful times in my graduate career. I always felt like I could reach out to her, so I'm so appreciative of that. And Jennifer, again, just a super welcoming, approachable scientist who I loved having on my committee because I felt like she helped to ground my desire to address these very applied, real-world questions in strong science. So to make sure I was really interpreting my data in the most rigorous way possible. And I appreciate that kind of moving more into this applied work that I'm doing, feeling like I have the skills to really address these problems using really good scientific techniques. So that was a wonderful contribution. And Miguel is the kindest, most enthusiastic person to have on a committee. I remember there were a few times that I was looking at data and feeling a bit discouraged, like, there's no effective varietal richness on profit. that's great, there's no effective bridal. So sometimes you just need somebody to, show you the light at the end of the tunnel, there's another way to look at things. And I'm very appreciative that he was willing to go on this interdisciplinary journey with me and welcome me into the world of economics, which was a bit intimidating. And then I want to just acknowledge the entire department, and I felt this so much when I came back today after having been gone for a while, that it was just this amazing energy of seeing all these amazing people and being welcomed back into the community. All of the people who've been in the Power Lab over the years, I've been here, he look a little amazed, who helped me think through my experiments and just being supportive when life and grad school gets tough. All the people who help me in the field, and then just all of the administrators here who make it so easy and such a joy to do our research. Never can take that for granted. And then the funding sources that gave me the flexibility to pursue these very interdisciplinary avenues of inquiry. And then there are three special women who so Erica helped me get through some really challenging data. And I do have experienced this feeling, but sometimes you just want to smash the computer on the wall. And we're just so confident and calm, and we're gonna figure this out. We're gonna get these hurdle models, and we're gonna think through this. And I just learned so much statistics from her, but just also how to calmly and methodically approach your problems. So thank you so much, and also moral support too. I told you I know myself after some years of PhD. And I don't think I would be here without Sharon. Just so much moral and emotional support. We all know that grad school just can be challenging. And she was just the whole time. And then Gayun in the top right, she is no longer at Cornell, but she was in the non-academic career services. And she's the one who really helped me get this job in California. And she would just stay late, even though she had a small child at home, and give me access to a room where I could do my interviews and give me the confidence to translate my academic skill set into something that might be appealing to a non-academic audience. So I just wanted to acknowledge these three women in their important role. And all the incredible friends both at Cornell and outside of it. I feel so lucky to have spent 7 years here with these amazing graduate students who have been intellectual support and emotional support, and just remind you that you have a life outside of your fieldwork and your data analysis, and to have fun. So thank you, and I did not have room to fit everybody on here, but you all have a special place in my heart, and I feel very lucky to be able to say that I couldn't fit all of my amazing friends this year, so it's such an honor to say that. And my California family, Tom and Carla, who are our roommates, but are like a second set of parents to us, that have just welcomed us out there and made us feel so connected to the community. All of my coworkers at OFRF who cheered me on in the past year, they've been finishing up remotely and are just really excited for me to pass this milestone. And then the amazing Zumba community in Santa Cruz that danced with me through my last year, finishing up, and my great Zumba friend Lynn, who just has always been so supportive and helped me laugh through some stressful times trying to get the dissertation submitted and presentation together. And then my family, who some of them are here with me today. So my parents, who have always supported me and believed me and just been willing to drop anything. I want to make sure that I'm okay and that I have everything that I need. To my brothers, who've always been my inspiration and my role models. Yeah, and my nephews, Leo, Jamie, and Kai, and their little sister Issa, who are really the future that I fight for. And then I couldn't have done any of this without these two very special people, Ricardo and Canela. You know me. You knew that Canela was going to be front and center. But Ricardo, thank you for believing in me at times when I just didn't know if I was going to be able to make it to the finish line, and getting excited with me about all of my research and going on this journey together. I'm so lucky to have had these two companions for me along the way. And now I'm finished. Oh, yes.
Sorry, I knew I would forget. So, there's gonna be a party on, Saturday night, that Katya and I are co-hosting, but it's at Katya's house. And, you are all, everyone is welcome, and the address is 151 North Landon, but just email one of us if you have questions, for Saturday night. Love to have you there.
And Ricardo has an amazing seminar on Friday that everybody can go
Hey, Andre, good to see you. Are you gonna make it to the seminar on Friday?
No, because
Okay,
field
no.
ecology all afternoon.
Oh, I'm so sorry, but no, it's okay. I understand. No. Yeah. No.
I need to get this meeting moving
Yeah, but some other opportunity, I'm sure.
Maybe it's raining like crazy and you have to come for it.
Let's see. But I actually gonna record the presentation, so maybe I can share the link with you.
I'll watch it.
Yeah.
Good luck.
Thank you for being here. Yeah. See you soon. ¿Cómo estás? Muchas gracias. Bien, bien, muy bien. Emocionado. ¿Sabes algo de Nicolás? Súper bien, algo. Muy bien. Sí, ahora en mi casa ojalá lo que conseguir yo creo que sí. Yo creo que ya cuando ellos hagan la exposición, solo solucionar el problema de los veranos, trabajando para porque había muchos pero sabes Pero no, bueno.
Thank you. Okay.
So,